Hello, I've been making some fairly slow progress on my app lately and looking for some long-term additions to it. And one of the features I would like to do would be to add a simulated equatorial mount to it. And what that would do mainly is once you start the equatorial mount so that it starts tracking what you see in the sky, the idea would be that it would automatically recalculate the altitude, azimuth, and camera rotation like this, so that all of the objects in the sky would remain fixed throughout the entire day. And that got me thinking about one of the trips that I took in 2019 when I started looking at how the sun and the various objects move through the sky. I went to a nearby shop that sells telescopes and equatorial mounts. And one thing that they said back then that took me by surprise was there were different tracking speed modes. And looking back at it now, it makes perfect sense why they would have the different tracking speeds. So I went online and I found a user manual for a basic equatorial mount, and they have different tracking speeds. They've got the celestial tracking speed. This would be for the stars, half of that speed. They've got solar tracking speed, and they've got lunar tracking speed. On a slight little tangent, while I was looking this information up, I did find telescope drive tracking accuracy, and one of the main issues, I guess, would be the right ascension motor speed may not necessarily be exact, and it could be just slow enough to cause a very slow shift throughout the evening. And one thing I would like to do is analyze this a little bit further to see just how bad it would be and if it really is an issue. In terms of the tracking speed of the different objects, the sun, the moon, or the stars, all the stars track at the same speed and always remain at the same distance apart from each other. So I just picked one of the stars, and the way I calculated the right ascension drift across the sky for each of these is based on the same principle. For any moment in time, I calculate where that object should have been a minute before, and before I convert those values to local altitude and azimuth, I keep the right ascension declination values, mainly looking at the right ascension, and I just subtract the one from the other and then multiply by 60 to give me the number of degrees in 1 hour. Based on the pattern of the analemma, I wasn't surprised at all to see the sun drift from more than 15 degrees per hour to less than 15 degrees per hour back to more than 15. When I got the thing to calculate each of these drifts, I was looking at the points where it would transition from being more than to less than. So the first one would be right here. This would be May of last year. It would just transition from more than 15 degrees per hour to less than. Then it would transition again back to more than 15 here around July or thereabouts. And then it would keep accelerating more than 15 degrees per hour until it reached the next point, which would be around November, and then transition back again in February. For me, this was easily explained by the Earth's axial tilt combined with the Earth's eccentric orbit around the sun. And the two being out of phase would cause 2 cycles per year like that. At the start, I was looking at the star right ascension drift, and I thought that I had only seen one. This one is a lot consistent, and you really have to look at the 5th, 6th, 7th decimal place to see the values change, except for that there's a bug there. So a few nights ago on Twitter, I made the incorrect claim that the stars went through a single cycle per year. Last night I modified the application to export the data into a CSV file. Then I loaded it into a spreadsheet, added a graph, and I got a very interesting surprise. I did not expect the stars to have 2 cycles per year. I thought there would only be one. And I've been kind of racking my brains ever since trying to figure this out. I landed on a few websites that talk about all of the intricacies. Some of them are very interesting. I'll leave the links to them in the description below. But this wiki page I find is very interesting, and it seems that the effect of obliquity also affects the stars. I'm going to have to do a little bit more research, calculations, look at the equations and whatnot. If you have any insights, I would definitely appreciate it if you leave it in the comments below. If you don't have any insights and thinking about these things is kind of your thing, then I offer this as an opportunity for you to think about it on your own before I make another video where I show my results and my analysis of this problem. And with that, thanks for watching. You know what to do. Don't forget to hit the thumbs up, and I will see you again in another video, hopefully soon enough. So, bye for now.